Good day, class. You're welcome to our physics class. And in physics today, we shall be looking at the topic Newton's motion. This is a topic under motion. Now, this topic is to study and calculate the effect of forces on bodies that are in motion. Now, before we will solve some questions under this Newton's motion, there are few things that we need to really understand. Now, the first thing is that force is what brings about a change in a body state of rest or of uniform motion in a straight line. So it is defined as any agent that changes or tends to change the state of rest or of uniform motion in a straight line of a body. And basically we have two types of force. We have the contact force and we have the field force. The contact force is a force which is as a result of the contact between two bodies when one body touches the other body and exerts some force such that it moves, while the force field is a force that is felt across a space as a result of some invisible forces there. Example of such field force are gravitational force, electric field force, magnetic force, etc. Now, talking about the Newton's first law. The first law is also known as the law of inertia. Now, it says that a body will continue in its present state of rest, or if in motion, will continue to move with uniform speed in a straight line unless it is acted upon by a force. The interpretation of this law is this: if you have a body as such, A, which is in a point. Now, when you apply, it's only when you apply a force to it that it will move. But if no force is applied to it, it will remain at rest. Or if a body like A is moving in a straight line, this body can be stopped from moving only if there's a force that is applied to it. The force can be visible or can be a field force or a contact force. It will be like we have a body that keeps moving and then it stops without anything. But don't forget that as a body is moving, we have the force of gravity that is acting on it. We also have a frictional force which is acting on it, and that is what can bring a body to rest. So when we talk about inertia, it is the tendency of a body to remain in a state of rest or uniform motion. So this body that is here now can remain at rest, and that is called inertia. Or when it is in uniform motion without any force acting on it, it is known as inertia. Now, a body that is moving has a mass and is moving with a particular velocity. And this too brings us to what we know as momentum. So a body that is moving has a momentum. And momentum of a body is the tendency of that body to continue moving in that straight line. Momentum is defined as a product of the mass times the velocity of the body. That is momentum. So we are saying now that if you have a large mass and a fast velocity, it will have a very high momentum. Now, using this fact about momentum, it brings us to Newton's second law, in which the rate of change of momentum of a body is directly proportional to the applied force, and it takes place in the direction in which the force acts. So we are saying that the force is directly proportional to the change in the momentum per time. That is the rate of change of momentum. A body changes momentum when acted upon by a force per time. So when we replace this proportionality sign, we would have K change in momentum over time, where this K is a constant. Now, having this equation without the constant, it will be F equal to change in momentum, that is momentum 2 minus momentum 1 over time. And we do not forget that momentum is mass times velocity. So if this is the final velocity minus the initial velocity over time, and that will give us our force. If we bring this t over here, we'll have Ft equals to change in momentum, where Ft is known as impulse, and that impulse is also known as mv minus mu. Next is, we consider a body that has a weight and is on a lift, right? Now, such a body, if it is stationary, that is, the lift is not moving, likewise the body staying there is not moving, we will have that. So for a stationary lift, we have that the weight of this body is equal to the normal reaction. The normal reaction is a force that is acting opposite, so the weight goes down and the normal reaction goes up, and all this equal to mass times gravity for a stationary body. 2, if we have the lift moving upwards, now it's moving upwards, that means that it has overcome the weight of the body. Hence, we have that r minus the weight of the body equal to the acceleration that is produced, equals to the mass times acceleration that is produced as a result of the movement of the body upwards. Then, if you have the lift going downwards faster than acceleration due to gravity, meaning that you have a mg minus the normal reaction to produce the mass times acceleration, mass times deceleration. So here is the equation for such. So the mg is now more than the normal reaction, and that is equal to mass times the deceleration. And lastly, we have when the lift moves downwards at the same acceleration due to gravity, whereby the acceleration of this lift downwards is equal to acceleration due to gravity. That means that they are going down at the same time. Therefore, A equals to G. At this point, the body will seem to not have any weight. So the body will tend to seem not to have any weight, and hence the weight is 0. And this term is known as weightlessness. Lastly, we have Newton's law. His third law states that to every action, there is an equal and opposite reaction. E.g., if there is a car which is stationary, and then here is another car which is moving towards a stationary car in this direction. Now it moves and it hits the stationary car. There is a possibility that this moving car can set this stationary car into motion. The momentum of this car is large enough. So it is possible that this moving car will set this into motion, but it will not move as fast as this original car was moving before. Another example is when you have a gun which is fired. As the gun is fired, the bullet moves at a very fast speed based on the mass of the bullet. Likewise, there's a recoil velocity on the gun which is felt on the hand or on the hand of the holder of the gun. So the momentum of the bullet, which is mb vb, is equal to the momentum of the gun, which is mg vg. This means mass times velocity, and here is mass times velocity. Now this brings us to what we know as law of conservation of momentum. It says that in a system of colliding objects, the total momentum is conserved provided there is no net external force acting on the system. Or it can be stated that the total momentum of an isolated or closed system of colliding bodies remains constant. Now what we mean is that when we have a body which is inside a container, this container is closed, meaning there are no external forces that are acting upon it. Now if there is a collision between these two bodies, the momentum before collision is equal to the momentum after collision. So in this case, let's say that the momentum of this first body before collision is m1 u1, that is the initial, And the momentum of the second body before collision is m2u2. It is going to be equal to the momentum after they have collided. Hence we have m1 v1 plus m2 v2, provided there are no external forces to it. Now this occurs in an elastic system. When we say elastic, when there is a collision of this body and this body, they hit each other and then they bounce back with a final velocity. All right, here we have two. But when we look at an inelastic system, whereby when this body hits the second body, the two of them will tend to move together. Now when they move together, that means that the final velocity is the same thing. So we have a situation whereby the initial momentum of the first body plus the initial momentum of the second body is equal to m1 plus m2 into bracket v. Now we have the two bodies now moving with a common velocity. Now in an elastic collision, momentum and kinetic energy are constants. Now when we say they are constants, here is what the equation for momentum will look like. Then for the kinetic energy, we will have it that initial kinetic energy of the two bodies, which is half mu squared, then half mu squared of the second body is equal to half mv squared of the first body plus half mv squared of the second body. Now don't forget that all this happens in an elastic collision. But in an inelastic collision, the momentum is conserved. So here it is conserved, but the kinetic energy is not conserved, and we have it as 1/2 mu squared plus 1/2 mu squared. That is the first body, second body, which is equal to 1/2 m1 plus m2 into bracket v squared. So this is an inelastic collision, and here is the calculation for the kinetic energy of in an inelastic collision, and here is the momentum in an inelastic collision. Now this is the momentum for an elastic collision, and this is the calculation for the kinetic energy in an elastic collision. All right, let's solve some questions under Newton's law of motion. First question: a body of mass 2 kg undergoes a constant horizontal acceleration of 5 meters per second square. Calculate the resultant horizontal force acting on the body. What will be the resultant force on the body when it moves with a uniform velocity of 10 meters per second? Okay, so in this question, we're told that we have a body which has a mass of 2 kg undergoing horizontal acceleration, which is 5 meters per second squared. Now we have to calculate the resultant horizontal force acting on the body. This is as simple as saying that force equal to the mass times acceleration. The mass is 2 and the acceleration is 5. So we have 2 times 5, that gives us 10 Newton as the horizontal force acting on the body. Alright, this next question says a car of mass 600 kg moving with a forward acceleration of 5 meters per second squared is acted upon by a constant resistive force of 1000 Newton. Calculate the force exerted from the engine to maintain this forward acceleration. Here we have a car that has mass 600 kg and it is moving with a forward acceleration of 5 meters per second squared. Now it is acted upon by a resistive force which is acting against it. So that is more like a frictional force, that is acting against it, and that is 1000 Newton. we have to calculate the force exerted from the engine to maintain the forward acceleration of the body. So we have to calculate the force exerted from the engine to maintain the forward acceleration. So meaning that there is a particular force which is more than the frictional force, right? And is able to produce movement of the body. So in this question, we are asked to calculate this particular force which is generated by the engine. So the force minus the frictional force, which is 1000 Newton, equal to the mass, which is 600 multiplied by 5. So this force equal to 600 times 5, that gives us 3000. Then we'll bring this minus 1000 over to this side to become plus 1000, and that gives us 4000 Newton. So here is the force produced by the engine to keep the body in motion. Now the B part of this first question says that what will be the resultant force on the body when it moves with a uniform velocity of 10 meters per second squared. Now, when a body is moving with uniform velocity of 10 meters per second, as it is said here, it means that it is not accelerating, meaning the acceleration equal to 0. Hence, the force equal to mass times acceleration. The mass in the question here is 2 kg multiplied by 0. Hence, the force is 0 Newton. The question says, a body of mass 5 kg moving with a speed of 30 meters per second is suddenly hit by another body moving in the same direction, thereby changing the speed of the former body to 60 meters per second. What is the impulse received by the first body? We have first body, we can call that A, and we have a second body, which is B. The first body has a mass of 5 kg and moving with a speed of 30 meters per second. Then we have a second body which we're not given the mass, and then we're told that it's changed the speed of the former body to 60. So here we're not given the initial mass and the initial velocity of the second body, but we're told that this first body, it has an initial, which is u, initial velocity of 30 meters per second, and then the final velocity became 30 meters per second after it was hit by a second body moving in the same direction. So we'll have it that the change in momentum is equal to impulse, which is Ft, that is impulse. And so we have it that the change in momentum is m into bracket v minus u equal to our impulse. The m in the question is 5 kg, then 60 minus 30, and so we have 5 multiplied by 30. That gives us this next question says object A of mass 20 kg moving with a velocity of 3 meters per second makes a head-on collision with object B mass 10 kg moving with a velocity of 2 meters per second in the opposite direction. If A and B stick together after collision, calculate their common velocity v in the direction of A. So we have a body A and a body B moving in opposite direction. There was a collision and the mass of A is 20 kg, velocity of A is 3 meters per second, and the mass of B is 10 kg and it's moving with a velocity of 2 meters per second. So what we'll do is we want to calculate the v, that is the velocity with which the two of them will move, and we're told that they stuck together and moved in the same direction. We'll find out the direction which they will move. Now from here we could calculate our momentum. Momentum here is 20 times 3 because momentum is mass times velocity. So 20 times 3 here is 60, and then 10 times 2 over here is 20. And so when they hit each other, since this is higher than this, this body will tend to push this body and it will move in, they will all move in this direction. All right, so back to our question. We have that momentum before the collision is equal to the momentum after the collision. So we have m1 u1 plus m2 u2 equal to m1 plus m2 bracket v, since they moved in the same direction. But there's something we need to take note of here. It is the fact that we would have a plus. Reason being that there is an opposite direction. So they were moving in opposite direction. Hence, this will be a minus. So we have it as minus. Now, when we multiply this, we have 60 minus 20 equal to, the addition of the masses are 20 plus 10 multiplied by the common velocity. 60 minus 20 gives us 40 equal to 30v. Hence, v equal to 40 over 30. So we are left with the velocity with which they will be moving is 4 over 3 meter per seconds. Next question says, a motor car of mass 800 kg traveling at 20 meters per second is brought to rest by brakes in 100 meters. Calculate the average braking force required. Here we have a car of mass 800 kg which is traveling at a velocity of 20 meters per second. A brake was applied and it stopped after it traveled a distance of 100 meters. We are asked to calculate the average force. Now, the formula that we need to use is force equal to mass times acceleration. We have the mass, but we do not have the acceleration with which it is moving. But we can get that from this information that have been provided over here. Now, part of the equations of motion is that v squared equal to u squared plus 2as. Now, in this case, a body was moving with an initial velocity. So the initial velocity is 20 meters per second. And a brake was applied to make it come to rest, making the final velocity to be what? 0 meters per second. Now, since we have this, it means there was a deceleration. So our acceleration here will be negative acceleration. So we'll use this information. Okay, the final velocity is 0 squared and initial velocity is 20 squared plus 2 times minus a times s, which is our distance, that is 100. And so we have 0 equal to 20 squared, which is 400, plus 2 times 100, that's 200a. Then do not forget that we have a negative in front of this. We bring this 400 over here and it becomes minus 400 equal to minus 200a. Now, minus cancels minus and we have a equal to 400 over 200. This cancels out and we have 2. So the acceleration is 2 meters per second squared. Now we've gotten our acceleration, we can proceed to get the average force, which is mass times acceleration. The mass is 800 and the acceleration is 2, so we have 1600 as the force. Alright, here's the next question, which says a block of weight 7 Newton rests on a level floor. The frictional force between the block and the floor is 1.0 Newton. A horizontal force of 1.4 Newton is used to pull the block for 4 seconds. What is the velocity of the block after this time? So we have a level floor and we have a block which is resting on it. We are told that the weight of this block is 7 Newton and there's a frictional force between the block and the floor which is 1 Newton. Now there's an horizontal force which is pulling it and the horizontal force is 1.4 Newton. And here we have the frictional force 1 Newton that is moving it in the opposite direction. Now the force pulled it for 4 seconds. So we have to calculate the velocity which with which the block moves. Now the first thing we need to do is to get the resultant horizontal force. Here we have 1 Newton and we have 1.4 Newton. So this 1.4 Newton is greater than 1 Newton. So we have the effective horizontal force is 1.4 minus 1 Newton, and that leaves us with 0.4 Newton. And so the body moves in this direction. Next is for us to find the velocity with which the body moves. So we have a formula that connects that is the impulse equals to change in momentum, which is mv minus u over here. So this is the velocity. The force which is pulling the body is 0.4. Put it for 4 seconds, which is equal to, the weight is 7 Newton. And so you can get the mass from 7 Newton, which is 7 divided by 10, that's 0.7 kilogram. So we have 0.7 kilogram here. Then we get the velocity. Now, the body started from rest and kept moving. So this velocity here is what we are looking for. The initial velocity is zero because it started from rest. So next thing is that we make v the subject of this equation. We have 0.4 multiplied by 4 over 7, and that gives 1.6 over 7, 2.3 meter per second. That is the velocity with which the body moves. Here's the next question, which says a player hit a ball of mass 0.3 kilogram, which was moving eastwards with a velocity of 10 meters per second, causing it now to move with velocity 15 meters per second westwards. The force of the blow acts on the ball for 0.01 second. Calculate the average force exerted on the ball by the player. So we have a ball which was originally moving towards the east with a velocity of 10 meters per second. Then here comes a force that stopped it from moving in that direction and to move in the other direction, which now attains another velocity of 50 meters per second. So what we'll do here is to bring in our formula, which is impulse equals to the change in momentum. Now this is the force which we are looking for, and we're told that it acted on it, and we're told that the blow acted on the ball for 0.1 second. So we have our force times 0.01 second equal to the mass of the ball was given as 0.3 kilogram. Then this is the new velocity with which the body moves, which is 15, minus, now we won't just take this u as 10. Why? Because we have a ball that was moving like this, 10 meters per second. Here comes a force that, number one, countered the 10 meters per second and then caused it to move on with a velocity of 15 meters per second, meaning that it is more like adding the 15 to the 10. So this minus 10 is because of it is an opposite direction. So this minus is for this, while this minus is the fact that the body had to move in the opposite direction. And so we have force times 0.01 equal to 0.3 into bracket 15 plus 10, and that is 0.3 into bracket 25, and that gives us 7.5. So F equal to 7.5 divided by 0.01, that gives us 750 Newton. So here is the force that kept the body moving in the opposite direction. This next question says a body weighing 80 Newton stands in an elevator that is about to move. The force exerted by the floor on the body as the elevator moves upward with an acceleration of meter per second is what? So in this question we have a body which has a weight of 80 Newton standing on an elevator and with an acceleration of 5 meters per second squared, the lift moved. So the elevator or lift is moving upwards, meaning that it has overcome the weight of the body. That is R minus W equal to the mass times acceleration to which it is moving, where W stands for weight, that is mass times gravity, and R is the force with which the engine of the elevator moves up, equal to the mass times acceleration. In this question, we are asked to calculate this force. Force minus the weight of the body, which is 80 Newton, equal to the mass of the body. We can get the mass of the body from here, which is 80 over 10, and that is 8 kilogram. So the mass of the body is 8 kilogram. So we have 8 multiplied by the acceleration with which the body moves is 5. So we have R minus 80 equal to 40. So R equal to 40 plus 80, and that is 120 Newton. So 120 Newton is the force exerted by the floor on the body. This next question says, calculate the apparent weight loss of a man weighing 70 kg in an elevator moving downwards with an acceleration of 1.5 meters per second squared. Here, a man has a mass of 70 kg and he is moving in an elevator which is moving at an acceleration of 1.5 meters per second squared. And we're told that elevator is moving downwards. We are aware that the formula for this is the weight minus the force with which the floor of the elevator is moving downwards equal to the mass times acceleration. Now, where this represents the weight of the body, and then we've identified this, then here is mass times acceleration. That is the mass of the body times the acceleration with which it is moving. And this is actually the weight loss. This is actually the weight loss because this is the weight of the person, but this which is moving down makes the body feel lesser in weight. And so the mass, which is 70, multiplied by the acceleration due to the acceleration with which the body is moving, that is 1.5, and that gives 105 Newton. So this is the weight loss of the body. The real weight of the person is 700 Newton, but this is the weight loss. Yeah, this next question says, a body of mass 12 kilogram traveling at 4.2 meters per second collides with a second body of mass 18 kilogram at rest. Calculate their common velocity if the two bodies coalesce after collision. So we have two bodies. A body is moving and the other one is at rest. So we bring our formula, which is m1 u1 plus m2 u2 equal to mass m1 plus m2 into bracket v. We use this because they joined together and they moved in one direction. Now the first body has a mass 12 kilogram and an initial velocity of 4.2. The other body we're told is at rest, and so this is 0. Then the two bodies, the first body has a mass 12 plus the second body, which is 18. Then we have to calculate the velocity. 12 multiplied by 4.2 yields 50.4 equal to 30 v. Hence, the velocity with which they move is 50.4 over 30, and that gives 1.68. So 1.68 meters per second is the velocity with which the two bodies move. Here's the next question, which says that a gun of mass 6 kg fires a 40-gram bullet at a speed of 120 meters per second. The recoil speed of the gun is what? Here we have two bodies, so we are going to have it according to Newton's third law of motion, that to every action there's an equal and opposite reaction. So the gun has a mass of 6 kg and the bullet has a mass of 40 gram, which is the same thing as 0.04 kilogram when converted. The bullet moved at a speed of 120 meter per second. What will be the recoil speed of the gun? So we have it that the mass of the gun multiplied by the recoil speed equal to the mass of the bullet multiplied by its speed. X equal to 0.04 multiplied by 120 over 6. Hence, the speed with which the bullet moves is 0.8 meter per second. Here's the question. It says that a particle of mass m, initially at rest, splits into two. If one of the particles of mass m1 moves with velocity v1, the second particle moves with what velocity? Here we have a body which is at rest and it splits, and so when it splits, it goes apart. And so we have it that this body was at rest, so we have mv and it splits into two, so we have m1 here and it has its own velocity. And then the second body, we're not given the mass of the second body, so we'll take the mass of the second body to be m minus m1. That is this big mass minus the small mass. So when you subtract it, you get this. Then multiply by its own velocity. And so we'll have it that m1 v1 minus m1 times v. Now we are using minus here because they split apart. Now from the information, the initial velocity, the body was at rest, so here the velocity is 0, so making this one to be 0. And then we have m1 v1 minus m minus m1 into bracket v. We move all this from this side to this side and it becomes m minus m1 into bracket v equal to m1 v1. Making v the subject, we have v equal to m1 v1 over m minus m1. So here is the speed with which the second body moves.